Now I am going to explain demodulation of PAM signal. So already we know modulation of PAM signal. What is the output of modulation of PAM signal? So finally we'll get the from modulation actual output will get, that is PAM, right? So demodulation of PAM is nothing but modulation. What is a modulation? Modulation is always changes. Input signal is converted to the actual output signal. So actual output signal is nothing but, if you are taking PAM, that the output signal of actual output signal is nothing but PAM. So if you are mentioning PWM, that the actual output signal is nothing but PWM. So with respect to according to whatever we are taking the signal, so the output is related to that will get, right? So here demodulation is nothing but whatever we are finding the output from modulation, that output is totally converted into the original message signal. So that is nothing but modulation input is what? So that is nothing but we are giving the source, right? What we are applying, that is input signal, and output signal is nothing but with respect to whatever we are giving the signal here, so related to that will get output, right? So now while coming to demodulation is nothing but actual output signal is nothing but, here will take modulation output. So that is nothing but modulation output is converted to the original signal. So that original signal is nothing but modulating input signal, modulation of input signal. This is output signal and this is input signal. So finally we know that is from this demodulation is nothing but modulation output signal is converted to the modulation of input signal, and in the modulation process the input signal is always converted to the actual output signal. So here demodulation of PAM signal, in that we are having only one block, that is ideal low pass filter. So here we are giving the applying the input voltage, input signal, and here we are applying the output signal. So input signal is nothing but, what is the demodulation of PAM signal input? That is modulation output signal. So modulation output signal, what is the modulation output signal? That is PAM signal. We are giving the input of ideal low pass filter. So that output is given, that input is given to the ideal low pass filter. So PAM signal is nothing but, it look like sine wave, but it will be converted in the form of pulses, right? So this is the input of, what is that, ideal low pass filter. So here low pass filter is nothing but completely eliminating the higher frequency components, any errors, any disturbances, so any higher voltage levels, so higher amplitude levels, that will be totally eliminating, and finally we are getting only actual output. That output is nothing but, what is the output here? Demodulation output, that is modulation of input signal. Modulation of input signal is nothing but, what is the input signal here? What is the modulation of input signal is nothing but, that is modulation signal. So that is nothing but, finally we are getting the output is here only message signal. Clear? So demodulation of PAM signal is nothing but, only we are giving input signal is nothing but, that is modulation of output signal is given to the low pass filter. Completely whatever we are having the disturbances, noise, that will be eliminated through this signal. So finally the pulses will be converted into the normal signal. So here already we are having in the pulses in PAM signal output, so that PAM signal pulses will be completely converted to the normal signal. So from demodulation of PAM signal we will get the actual output of modulating signal. So this is the demodulation of PAM signal. So now I am going to explain the second thing is nothing but, that is PWM signal. So PWM signal is nothing but pulse width modulation. So pulse width modulation is nothing but, here changing the characteristics is nothing but, that is width. So the width of the carrier signal is changes according to the modulating signal. That is nothing but instantaneous values of the width of the carrier signal is changes according to the modulating signal. So here the pulse width, whatever we are having the pulse width in the signal, that width completely changes with respect to the modulating signal. So in that we are having three blocks, that is input of modulating signal is given to the one block, and the sawtooth generator is given to the another block, and the comparator is given to the, it is connected to the one device, that is. So here this is nothing but, generally we can call as, that is comparator. So always we know comparator is having two terminals. The two terminals are nothing but, one is plus sign and another one is minus sign. So plus sign is nothing but it is always called as the non-inverting terminal, and the minus sign is always called as the, what is that, inverting terminal, right? So here we are having the two inputs. Now the two inputs are nothing but modulating signal and another one is sawtooth generator. So modulating signal is given to the non-inverting terminal of the comparator and the sawtooth generator is given to the inverting terminal of the comparator. So here modulating signal is nothing but, in the diagrammatic representation we are taking sine wave, right? So and the sawtooth generator is nothing but, already we know sawtooth generator symbol is nothing but, what is the sawtooth symbol, right? So this is nothing but sawtooth symbol. So now I am giving the modulating signal as input of comparator and the sawtooth signal is given to the inverting terminal of the comparator. So here finally the comparator is having only two input levels. So here we are taking modulating signal as sine wave and the sawtooth signal generating this sawtooth wave. So one thing we know, that is sawtooth signal amplitude is always greater than the modulating signal of amplitude. So that is nothing but, here we'll know one thing, that is sawtooth amplitude is greater than always modulating signal. So that is nothing but sawtooth signal amplitude is must be greater than the modulating signal. So first I am giving the two inputs, that is nothing but, at a time I am applying the sawtooth signal input. Sawtooth signal is given to the input of inverting terminal and the modulating signal is given to the non-inverting terminal of the comparator. So what happens means, here we are combining the two signals, that is one sine wave and the another one is sawtooth wave, right? So what happens in that output is nothing but, so compulsory the comparator produces the one output. That output is nothing but, if the comparator output is positive, so that is nothing but comparator output compulsory it will be produced as the some output. That output should be in the case of positive level. At that time the sawtooth signal amplitude, the sawtooth signal amplitude is at minimum level and non-inverting terminal of the output is at higher level. That is nothing but non-inverting terminal goes to higher level. Okay, so here one thing, first output is nothing but, so if you are applying the two signals at a time, so compulsory the comparator produces the one output. So that output is nothing but, that may be sine wave or square wave, whatever the output is present at output side. So if that output is at positive level, so that is nothing but, positive level means we are producing the one output. So that output may be, just consider that output may be square wave. So if the comparator output is at positive level, right? So positive is nothing but, we are showing maximum level. So this is the positive level and this is the zero level. So that is nothing but, the comparator output is at positive. At that time the non-inverting terminal will be in activated position. So the sawtooth signal should be in the minimum level. So that is nothing but, here the sawtooth signal will be in minimum level. So this is the sawtooth position and this is the modulating position. Clear? So once the comparator output is at positive, so then the modulating signal is at positive position is nothing but, it is in higher position and the sawtooth signal goes to the minimum level. So at that time the non-inverting terminal output goes to the higher level. So that is the first case. And the second case is exactly opposite. So that is nothing but, comparator output is at negative case. So at that time second thing is nothing but negative case. Negative case is nothing but, we are shown by like this. So at that time the comparator output is at negative, the sawtooth signal raised into positive position. So suddenly it will be raised into maximum position and then only inverting terminal goes to the higher level. Clear. So once the comparator output is at positive level, at the time non-inverting terminal will be in activated position. Clear. So if the comparator output is at negative position, so in that case inverting terminal will be in activated position. So at the time sawtooth signal goes to the rise into peak level, and after that it will be producing the output. That output will be reaches, inverting level will be reaches to the higher position. So then only it will be converted to the width. So finally the output becomes, so we are combining the modulating signal, and another signal is nothing but sawtooth signal. So the final output will be like this. So how to calculate it in the width means, so like this will convert it to the widths. And the next thing is here. So that is nothing but where the modulating signal will be combined to the, what is that, sawtooth signal. At that time only will producing the PWM signal. So the final output becomes like this. Clear. This is the PWM signal. So that is nothing but once the comparator combining the modulating signal and carrier signal. So here carrier signal is nothing but here we are taking the sawtooth signal. This is the modulating signal and this is the sawtooth signal. So in general we can say that sawtooth is nothing but we will mention as carrier signal here. So once the combining sawtooth and modulating signal, it will be producing the width of the pulse modulation signals. So how to producing the widths means, once the comparator output is at maximum level, that is nothing but positive position, so then only non-inverting terminal will be in activated position. So then it produces the sawtooth signal goes to the minimum level of output. Clear. So once the comparator output is negative case, at that time, so the sawtooth signal rise into peak position and it will be inverting terminal will be in activate position, then it will be produces the maximum output. So how to producing the pulses means, once combining sawtooth signal and modulating signal, so once touch into the modulating signal in sawtooth signal, at that case only we are producing the pulses. Okay. So like this we'll get the PWM signal output clearly. So this is the modulation of PWM signal.